speed on what's going on, and we'll keep everybody moving on that. So the rest of you know me, but Farah, let me introduce myself. My name is Brad Fessler. I am the Professional Development and Content Manager here at Sphero. I spent 15 years in grades 9 through 12, technology and engineering education, as well as 4 years in higher education as well, teaching engineering concepts. So I'm no rookie to the classroom. I've been there. I've used Sphero products, including Bolt, in my own classroom. So I understand what it's like to use these devices in room with students. So feel free to ask questions when we go through there. So does everyone have their Bolt and a programming device with them? Give me a thumbs up if you do. Yeah, okay. So we got some programming. Okay. It's all right if you don't. If you do, I'm going to give you a few minutes, and here's your challenge. I want you to use some of the role blocks that are there. And last time we drew a square using our role blocks, or at least learned how to do that. Now I want you to program a 3-dimensional cube. Okay, so think about those angles, what this might look like in here. And what we'll do is once we run our program, we'll take a look at our data that the robot records. But if you wanted to do this with students and actually see what they did, you can use like butcher paper or rolled paper of some sort. Take a 16 to 18 ounce plastic cup, put it over the top of Bolt, and using 2 rubber bands, strap a marker to the side of the cup, and Bolt will drag that cup around and allow you to draw out that path, right? So it allows us to see what all of that looks like with it. If in our case, we're not going to draw because we don't have all that stuff with us tonight, we'll take a look at the data that our programming device records to kind of get some feedback on what our robot really did. So if you're looking at my particular design here, I started right here at this corner, right? So the bottommost point of my cube, and then I drew in this order. Does it mean it's the best way? No, there's plenty of other ways you could draw this. What I will tell you is this pattern gives you the least number of repeated lines. So line, you'll see it's listed as line 7 and 8. You'll have to draw that line twice in order to make the whole shape. So roll block wise, we are going to need 10 roll blocks to do this. Think about those angles, what that's going to look like here with everything, and go ahead and get yourself programming. And don't forget about the delay between the roll blocks. Adding a delay between the roll blocks will give you a lot more accuracy. So with that being said, I'm going to give everyone a few minutes to just go ahead and program. Even if you don't have a Bolt sitting in front of you, go ahead and start programming with this. You can always test this later after our session is over, once you have a Bolt in front of you. Farah, do you have any experience in Sphero EDU or no?
No, I'm a first timer in everything. So
Okay.
I just want to be familiarized with it and have an understanding.
Yep, sure, no problem. So while they're working on that, what I'm going to have you do is on some kind of device, download the Sphero EDU app. So whatever kind of device you have in front of you, whether it's Windows, Mac OS, an iPad, anything that's Fire OS or a Chromebook, Android device, you'll be able to download it from the appropriate app store. And the app is called Sphero EDU. All right.
Got it, thanks.
Yep, no problem.
I have played with this with my kids before, where they literally just got on the app and just started fooling around and playing around with it. Even my littles for like kindergarten. Are we looking still at just basic blocks? We're not looking at any of the super special blocks?
We will after this I'm calling this a warm-up exercise, but it's certainly not an easy one, right?
No,
It's kind of
that's why I was
reviewing
asking
some
if
of
we were
the
using
things we
anything
did.
special.
Nope, but we will get into some more advanced things here in just a few moments.
All good.
And Brad, I'm interrupting just for a second to say to Farah that we also can share the introductory Bolt webinar with you. We can send you that as well, and then some other materials. So, if you feel a little lost today, we can give you some other support.
I would
Yeah.
love that. Thank you.
I would
Haley,
too, because I
that
couldn't
shouldn't
attend the
come
last one. Same.
Okay.
Oh, yeah.
We're carrying on.
All right, sounds good, no problem. I'm giving everyone a few more minutes to work on this because this is not a quick and easy problem. I'll give everybody a little more time to work through that. I'm gonna get my demo set up so that everybody can check it out here.
And Brad, you said that the light should be pointing back at us, right? In the opposite direction of where it wants to go?
Yep, correct. Yep, correct. The blue light when we're aiming is the tail light. That is correct. So a couple pointers while you're working on this. Some things to think about when you're doing this with students is make sure you run their program on the paper without the cup first, or even with the cup, but without the marker, just to make sure we're not drawing lines on our floor or whatever other material we're working on. We don't want to put permanent marker on a desk or on carpet or anything like that. So always test just to be sure. Note that adding a cup to the top of bolt will make it travel less distance because you're adding some resistance to the travel of bolt. So that's something to keep in mind when you're going through there. Also, there is more than one way to solve this. There's actually probably a couple hundred ways to solve this because you could draw these in different orders. Your drawing might not start with a box like mine. It might start with a flat face on one side and then add angles to it. That's a possibility as well. If you were talking in the CAD world or the drafting world, the image that I have up there would be considered an isometric view, meaning it's on 30-degree angles to start with. For each of those bottom lines from that bottom vertex where it comes in, so this point, that would be a 30-degree angle, that would be a 30-degree angle. But it doesn't need to be that way. It could be a flat square to start, and then your angles coming off of it, which would then change that potential angle. You're looking for something that is not perfect when you get your finished product here. Even your data is not going to be perfect, because when you redraw a line, there's always that possibility that bolt didn't travel the exact same distance due to resistance on the floor or anything like that. So what does this look like when we see a finished product? So let's take a look at how Bolt will actually do this. So here I'm gonna, let me see if I can lose a little more light there. And I'm gonna run this program so we can see what it looks like. All right, so that might be kind of hard to follow on screen, but let's take a look at what that data looks like on our iPad. So here on my programming device, this is what my finished product looks like. And what I had on screen was that isometric square, and what I programmed would be that flat face. So you can see the flat face of the square kind of facing us, starting at the origin there at the 0, 0 point, and then moving from there. So you're looking for some kind of data that looks like this, right? This is a really refined example of this. So don't feel that your students are going to get this, or you are going to get this on the first shot. This is something that I have done multiple iterations of to get it like that, nor are you going to be able to do that in the 10 minutes or so that I gave you to do that. But it gives you an example of that warm up using those roll blocks to get that moving. So with that being said, let's look at my actual program here. So I'm going to zoom in because the program is super repetitive. So I set my light mainly so that you could see what it looked like when I started running my robot on the floor. And then I set a roll block in there. I started at a heading of 0 to do my first vertical line. So if I'm looking at this particular example, I actually drew line 2 first in here. And then I have this kind of pinkish looking block that says speed. And what I did here was I created a variable called speed. What this allowed me to do in here is if I needed to change the size of my square, or say I needed to give Bolt more power to push the cup, instead of changing every single roll block individually, all I'd have to do in here is go in and choose edit variable, and I can change the value of that variable. So if you're looking to get that more advanced kind of programming in here, what that allowed me to do was make an easy edit to my program by using that variable, right? So easy way to do that. Then I set my time. You could also do the exact same thing with time if you wanted to. You could add that as a variable as well. Notice that between each of my roll blocks, I have a delay in there to make sure that Bolt comes to a complete stop before turning and going to the next one, so I don't round off all of my corners. So what do all these angles look like? Just as a reference, 0 for my first line, 45 degrees. I was working with increments of 45 here for my angles, 90 degrees, 180. Then I'm coming back the opposite direction at 225 because I'm redrawing that line. Then I have 0, 45, again, 225 to redraw, 270, 180, and then 90. And that will give you a 3-dimensional cube. And if you need any of those numbers, if you're looking to do an exact replica of this as an example, just let me know at the end of the session. I'll gladly pull this back up and give you all those numbers again to go through it. I just did this activity for the first time 2 weeks ago at an on-site PD, and everybody seemed to really love it. I used it as a warm-up activity because they had already had experience doing some basic movement with the robot. So this was, again, our warm-up activity. It is not a super easy activity, but it is a lot of fun once you get it figured out and you start actually drawing this out with a cup and a marker.
Could you have set your time as the variable also?
Yep,
Keep from having-
absolutely. Yeah, absolutely. So you could completely set so we set the speed here as a variable, but you could also set the time as a variable. And then it would allow you to adjust the size of that square, not only by adjusting speed, but also adjusting the amount of time that it's rolling.
And I didn't know until we did this one, anything that circle you can replace.
Yeah, so
Variable.
yeah, so you'll notice that Sphero EDU inside of the blocks has different shapes. And we'll see this again in just a moment. But you can see a color here, main LED, has a particular shape. So then when I go into different block categories, you can see here there's a block for random color. Notice the shape, right? It's the same as that. I can't put it under any of the oval parts, but I can put it under the octagon shape here that I can put in for the colors, right? And then if we're looking at here we have the time, right? I could put in, say, like a random time. I could bring a random integer into here, and then you could set in randoms, right? So those are all based on the shape of that block. And we'll also see that when we go under controls and we do loops and if else statements, right? So if else, we can see there's a different shape for the true false part of an if else statement. Again, it all depends on what the shape of the block is, the opening it can go into. So great observation. Great observation.
Thank you.
All right.
And the same
So-
thing real quickly, you can also have just changed it at the top and put a set block, set speed to 10, and then you only have to change it once.
Yeah, absolutely. So there's two ways to do this. You could use a set block there, or what I did was I choose to edit my variable. And when I look at the variable right here, I have the number, and then this number next to it is the initial value of that variable. So I could go in and set it there, or I could use that set block to change it in the code. Either one will do the exact same thing. Yep, great question. All right, so we got ourselves moving here a little. Now it's time to play a game. So kids love to play games. We love to play games, right? So we're going to play an old-time classic of rock, paper, scissors, and we're going to put a high-tech twist on it using our bolt. So there is an activity for this. You can see there's an activity code there that can be searched inside of Sphero EDU. So you might want to either take a picture of this or maybe write down that activity code if you think this is something you might want to do later. That activity code will take you right to the Sphero EDU activity for this. All right, so let's take a look. Let's see how we're going to build this. So first thing we're going to need to do is we're going to need to create what we call a variable, right? So we already talked about the variables just a tiny bit there with speed, but let's actually build a variable. So I'm going to start a whole new program, and I'm going to make sure I'll switch over here so you can see it. I'm going to name my program. I'm going to hit blocks, and I'm going to use a Sphero bolt to create that. I'm going to hit create, get my coding canvas. This is my blocks canvas here. And the first thing I'm going to do is I'm going to go over to that variables menu, and I'm going to create a variable. So I'm going to hit that button, create a variable. I'm going to name it. In this case, I'm going to name mine RPS for rock, paper, scissors. And I'm going to select the type of variable as a number. Okay. There's 4 different types of variables that you can do. There's string, number, a Boolean, which is a true-false statement, or a color. Something to note that a color as a variable is essentially a 3-value variable, right? And that doesn't make sense at first, but when you think about it, each color has a value for red, green, and blue, right? So there's a number 0 through 255 for red, a 0 through 255 for green, 0 through 255 for blue. So what the color variable allows us to do is set that color using those 3 values. So we're going to choose number. And if we wanted to, we could adjust that initial number. I'm going to let mine to 0 and hit the check mark. I don't need to change that. And now what you'll see is I have 2 new blocks in there. One is the rock, paper, scissors, the RPS block. And then we also have the set RPS block that's in there. So we're going to need to start by building our OnStart program here. So I'm going to jump back there for a second and build that OnStart program. So we have our variable and we have our OnStart. There's 2 things we need to take note with this one. One, we're going to give feedback in multiple forms. So we're going to give audio feedback and visual feedback with our bolt. And 2, bolt doesn't need to go to the floor for this activity. So it's going to be handheld, right? We think it's a robotic ball, so it has to roll around on the floor. Well, when you pick it up off the floor, it's equally as powerful because you have all of those different options and sensors to work with in here. So with that being said, I am going to start programming my OnStart here. And the first thing I'm going to do is under movements, I'm going to find that stabilization block and put it in here. So the way stabilization works is, if you'll notice, when Bolt is running, that LED matrix is always trying to face up, right? That's because the robot's stabilized. In this case, we're going to shake it, but in our hand. So because of that, we don't want stabilization on. We're going to turn it off. So all I did was tap where it said on, that toggled it to off. So you can see every time I tap on that one, it'll change between on and off. Now, blow that up here a little more so we can see that. Then we're going to add, like I said, some visual feedback. So under the lights, we're going to scroll way over and we're going to find scrolling text. Scrolling text. And I'm just going to type in there, shake me to play. You could put in whatever you want for feedback for your players. You can set whatever color you want in there. And you can also adjust the speed. So if you find that it's scrolling too fast and you can't read it fast enough, right, you can lower that speed a little. Now, at the end of this, we also have that wait portion of the block. And if you tap on that, it's going to set it to continue. Remember that a computer only reads 1 line of code at a time. It'll read the line of code, execute it, and then go to the next line of code. If we tell it to continue here instead of wait, it's going to read that line of code, it's going to start scrolling that, and then it's going to immediately go to the next line of code there. So it just gives us some more time for 2 things to happen at once. So I'm going to bring that in. Then I'm going to go to sound. and I'm going to bring a speak block in there. And I'm going to say the exact same thing I did there. So I'm going to say shake me to play. And notice that I'm going to leave this one at wait. So it's scrolling the text. Now it's going to speak the text while it's scrolling. And then when it's done, I'm going to add one more block, and I'm going to change my main LED to green. And I'm going to do that so that I know everything's done. It's ready to go. Right? It's ready for me to shake it to start the game. These are the only things that will go under that on start program event. Everything else is going to happen in a separate event. Give everyone a moment or two. Just give me a visual thumbs up there on your camera when you think you're ready. Good to go. All right. Yep. Okay. All right. So once we have that, we're now going to build an event. So under events category, we have a bunch of different events that are in here. And the one we're going to use is on collision. So I'm just going to drag on collision up here somewhere onto my canvas. So what this event does is it looks at all of the different sensors that are inside of there, and it tries to detect when Bolt runs into something, right? And we're going to simulate Bolt running into something by giving it a shake. So we'll just pick Bolt up in our hand, give it a quick shake, and that's going to make Bolt think that it ran into something. So with this, we're going to use that set RPS block there. And if you don't have that drug out on your canvas, you'll find that under your variables category. Just a reminder that those categories and the blocks are all color coded to the same color. So there's a particular color for every block that exists under variables, just like there's a different color for every block that's in operators and so on. So now we want to set that to a random number. And the reason we want to set it to a random number is we have 3 possible outcomes for rock, paper, or scissors. So I'm going to go to the operators category, and I'm going to choose random integer. Notice that it is possible to also do a random float. If you're not versed in the programming world, a float is a number with a decimal point, right? We don't want to use a decimal point. We want 3 finite outcomes. So we're going to use integers for this. And we're going to set that from a minimum of 1 to a maximum of 3. Minimum of 1, maximum of 3. So when you shake Bolt, it's going to set that variable to either the number 1, the number 2, or the number 3. And we're going to assign one of those numbers to rock, to paper, or to scissors in that. So you'll get a random outcome every single time. Now, once we've set that variable, we now need to check and see which variable or which number that variable was set to. So we're going to do that under the controls menu by grabbing an if statement. We're going to bring that if statement in here. And the way an if statement works, if a particular condition is true, then anything that's inside of that if statement will run. If it's not true, it's going to skip over that code and go to the next line of code that's outside of the if statement. So we want to compare the value of our variable RPS to a number. So I'm going to go under comparators, and I'm going to grab the first one, and I'm just going to drag it out on the canvas here. And then I'm going to drag and drop RPS, the variable, inside of that. So I dropped it inside of there. Then I'm going to take this whole block and drag it into where it says true. And I'm going to make that value 1. So if RPS equals 1, then something is going to happen. And give you all a moment. Get through that. When you're good, just give me a thumbs up there. Awesome. Awesome. I don't want to leave anybody in the dust here. So once we have our if statement, we need to put inside of it what we want to happen. So I'm going to go to sounds and I'm going to get speak because I want to give audio and visual feedback. So under speak, I'm going to make this first one rock. And I'm also going to set that to continue. So it speaks, and then it immediately is going to show me a matrix animation. So under my lights category, I'll go to matrix animation, and I'll bring that in. And here's where the artistic ability comes in. And that part of the fun is we can make this look like whatever we want. So when I tap on the little matrix icon in the block, this is what I'm going to see. Again, just a review from last time, there's tons of animations that are in here, pre-made. You can use those if you want, but you can also make your own. So I'm going to hit the little plus sign in the kind of the upper left corner here. I'm going to hit that, and I'm going to see a frame. Now for a rock, I'm going to go through. I'm going to make kind of a brownish color here. I'll go something like that. Maybe darken it a little bit by bringing the brightness slider down. And I'm going to take that color. Now I'm going to go through here and I'm going to draw in my rock. So I'm just kind of painting in those pixels. And if you want, you could just let it a rock like this. I like to mix things up a little. And then I'm going to add yet another color to this. I'm going to bring in like kind of a white color. Oop, I don't want to replace that color. I'm going to choose another one. Then edit that color. Sorry. And then I'm going to draw the letter R in here so that I know what this actually is. Right. So there I have my rock that I've painted in. Don't judge me too much. I'm not a great artist. I apologize. Once I have my design in here the way I want it, I'll go ahead and hit the check mark and put that in. You could draw whatever you want in here. Like, give your students that artistic license to come up with some things. They may even go in and make different frames and actually make it move, make it animate. They could do that by hitting the little plus sign that's down just above the color palette on the right-hand side. They can create more frames and make it animate through those frames. So once I'm happy with my rock, I'm going to hit the check mark and I'll see my block will look like this. See a preview of it.
So if they did frames, they could possibly do like ROCK.
Yep,
Okay.
100%. Yeah. So while you're working on that, I'll do that. I'll edit it. Right. So I could copy this frame and I'll get rid of the ones that I don't need. Do that, or I'm going to duplicate that frame again. And duplicate that frame one more time. Oop, didn't do such a good job on that one. There we go. So now I can also adjust the speed of that animation if I wanted to, and lower this down. So if I want it to take 2 seconds to play that, I'll drop it to 2 frames per second. And I'll show you a cool trick to this. While you're in your animations menu, the little bouncing Sphero icon, it's right above the M in my animations. If I hit that, at the bottom it says preview animation on robot. Oop, I gotta connect to my robot again, sorry. Get connected. And we can actually preview the animation right on the robot, which is really cool to kind of see what that end result will look like. So bouncing Sphero icon, then I'm going to hit preview animation. It's going to start going through there. I'll switch over. I don't know if how easy it'll be to see this, but let's see there. Oh, it might be too bright in here. I don't know if we can see it. You'll have to trust me on that it's actually working, but it is playing through there. It's a little too bright to see on camera, but it is playing through those animations for us in there. And you can see here on my screen, those are my 4 frames of the animation. So once I have that, I need to put a delay in here. And the reason we need to put a delay in here is we need to specify how long we want our animation to play. So remember that the student's going to have to turn the robot and look at it. So give them enough time. So I'm going to say like 3 seconds is usually enough to actually see it, see the animation. Don't forget that the entire animation, in my case, takes 2 seconds to play. So if I want to see it play through twice, I can set it to 4 seconds. Then under our lights, we're going to clear that matrix. So it's going to stop playing my animation. And then I want to set my display back to green. So instead of redoing my main LED, I'm just going to long press on the main LED over an OnStart program. And I'm going to choose duplicate. That just makes a copy of it. And I now have my on collision if statement there. So I got that. See if I can get it all on screen there nicely. So you should have something that looks like this. Now we have 2 more possible outcomes. So instead of rebuilding this whole thing 2 more times, the easy way is to on the if statement, long press on it, and choose duplicate. And what that'll do is it'll make a copy of that entire block. I'm going to put it after the other if statement. And now I'm going to edit that. So I'll give you a second so you can see what that looks like. And then we're going to take that RPS equals. We're going to change that to 2. We're going to speak the word paper instead of rock. and then we're going to change our animation. Now, this is important. You don't want to edit this animation. If you edit this animation, it's going to change the rock as well. So what you want to do is in that upper left-hand corner, you have the plus sign. Hit that plus sign. It's going to make a brand new animation. So in this case, I'm now going to go through and I'm going to make this my paper, painting all those in. And I'm also going to put the letter P in here. So I got my little crinkled corner of my paper. I don't know about you, but I can never keep paper perfectly flat. There's always some kind of crinkle in it there. So I got my crinkled corner of my paper. Everything else there is filled in white with the exception of the letter P. I put in as a different color. And in the spirit of doing it as an animation, I'm going to duplicate that frame. And I'm going to unfold my corner one row at a time. Like that. So I can hit the little arrows. I can see what that will look like as I cycle through that animation. Again, this particular animation is set to 4 frames. So if I go in and edit that and change my speed, I'm going to set my speed to 2 frames per second. That means each frame of my animation is going to be a half second long.
Brad, I think I missed a step with how you made your frames.
Okay.
I don't have mine stacked the way you do. They're all separate.
They're all okay. So you were hitting the plus sign at this one every single time.
Probably.
So I'm gonna go into the animation itself. So right here I have my 2 animations. I have rock and I have paper.
Mhm.
I'm gonna click on my paper animation, make sure I have it selected, and then I'm gonna hit the pencil. And what that's gonna do is allow me to edit.
Mhm.
And then here, just above the color pickers that are down there, all those color samples, you'll see a plus sign.
That's where I
That
need to.
adds a blank frame, or the one that's just to the right of that, it looks like 2 squares and a plus sign. That will duplicate the frame, and then you can make an edit from there.
Got you.
Yep. And once you have your paper animation set up, just give me a thumbs up. You know, it'll take everybody a few minutes. right, and as you finish up your paper animation and that if statement, we have one more if statement to do, and it's for scissors. So press and hold on the if statement one more time. Choose duplicate. I'm going to drag that statement down here, and I don't want it inside the other if statement. I want it outside of that one. And that RPS value will be 3. And I'm going to do scissors. And I'm going to do a new matrix animation yet again, one more time. And I'm going to do like a silverish color here. And I'm going to build my scissors. Something like that. And if I was going to make this an animation, I might start to move everything one frame at a time here. Do something that looks kind of like that. And I can always edit that speed again. I'm gonna drop that down. Again, you don't have to make them animated. You can do a matrix animation and just make it one frame, and it just displays that for one frame. Adding the animation part of it is just fun when you see it. So I'll let that up for another couple moments.
Scissors. Rock.
Once you have all 3 if statements completed, I know this is going to be pretty hard to see on the screen, but I'll leave them as large as I can, but with all the code exposed here as best I can, so you can see what that looks like. And then start your program, connect the bolt if you're disconnected, start your program. What you'll see is bolt will turn green here. Then you can give bolt a shape, and you're going to see your animations in there. And you should hear bolt read out what the result was. And then when it's done the animation, it should switch back to green. I'll bring that back up so you can see it. So now you can challenge your students, coworkers, significant other, whoever, to a game of rock, paper, scissors, right? And if you don't have a good poker face, and they always say they always know what you're going to throw, well, now you can really mess with them because it will be 100% random because you're using a random number generator to pick one.
Can I ask a quick question?
Absolutely.
We made a variable, which is awesome because now we know exactly what the variable is. But just we could have also done random integer 1 to 3, right? And then it would just would have it wouldn't have been as cool. But
Yep.
okay.
Yeah, 100%.
That's what I find so cool about all of these things. Is there's 70 different ways that you can do it, and all of them are correct.
Yeah, absolutely. But that's a key thing to point out to students too, is just because yours might not be the same as mine doesn't make it wrong. As long as the end result is a functional program there, that's what you're looking for, right? So that's the fun part about that. And of course, you can get your students then having a good fun rock, paper, scissors battle here, just like our baseball players and mascots, right? As you go through, it's just a lot of fun to do these kind of game designs with the students, and they're learning some coding concepts at the same time, right? So I know that was a lot of stuff in a short amount of time, but you just made a really pretty cool program. You invented a game in that time frame, and you at least started to draw a 3D cube with your robot. So you did two pretty advanced things in an hour. So what kind of questions do you have?
Scissors. For like right now. But I know the other day you mentioned that did you say the Spheros communicate with each other or something
They
like
do.
that? Okay. And is
Yep,
that,
they
is that
do.
on the EDU page, or can I look on the
There-
other thing to find out more
Yep,
info?
there is. Yep, there is some stuff on Sphero EDU about that. But if you're looking at your coding categories here, there's one, it's kind of orange in color. It says communications. And when you hit that, you can see there's all kinds of different communications things that you can do here, right? So you can broadcast on a certain channel, right? So when you broadcast, that means you've turned that signal on and it's going to stay on the entire time. The reason you might do that is you might broadcast the channel for one Sphero and then have another Sphero follow that channel. And by doing that, it allows us to program one Sphero to go on a path and another Sphero to follow that same path, right? It's going to follow it around. Remember that the communications are infrared, so they're line of sight. Okay, so like an older style TV remote. I have to say older style now because new TV remotes a lot of them are Bluetooth, right? It also has the ability to evade. So instead of following, you can evade. And then you can also send a message using 8 channels, 0 through 7. And the cool part is, under your events tab, you can do on message received from one of those channels and have the other bolt do something based on the message it received. So you can have them communicating back and forth on different channels to see to get them to respond to each other, doing different things. So you can send text messages that way. You could send movements, have them change lights based on what the other one said. All kinds of really cool things there. And if you're looking for communications activities, if you go under Sphero activities, we have under some of our blocks activities, you can send and receive some messages that way. So check out your blocks 1 through 8. It'll walk you through all those basic blocks, even up to communications and doing some things that way with variables, communications. Hot Potatoes, another fun game to play. You can do some things with the flashlight function. So you can use that onboard ambient light sensor that's in there. Again, a whole lot of fun.
And you said these are Kindle Fireable.
Yep. Yeah, they can. There is a Fire OS version of the app, so you can use that. You can use it's iOS, Mac OS, Windows, Android devices, which includes Chromebooks, as well as Fire OS.
Awesome.
Keeps our programmers very busy.
Sure it does.
All right. Anyone else have any other questions? That was a quick hour. Hopefully it went as fast for you as it did for me.
It was
Thank you.
jam-packed.
It was jam-packed.
In a good way.
Yes.
I
So-
like how you bring the old school in for us older folks here. Rock, paper, scissors, and hot potato. It gives me
Oh.
hope.
Well, there is. So it's funny you say that because the blocks 4 activity to go even older is Pong, the Atari version of that. It is also Pong,
That's
right?
awesome.
So you can play Pong with your Sphero bolt rolling around on the floor. Your foot is the paddle, right? And you can make it bounce back and forth. As also a lot of fun to watch the kids running around the room trying to stop bolt so that they don't lose, right? Lose a game. It's a lot of fun.
I love it.
Yeah.
I'm dating myself again. I was thinking the Pong, but after that, the only video game I think I ever played, I don't think it wasn't a video game. Well, maybe it was. It was called Centipede. It's kind of like
Yep.
the Donkey Kong games. Yeah.
Yep.
Anyway. I digress. But anyway, well, thank you so much, Brad, again, for an awesome training and lots of really cool tips and
Yeah.
things to connect to the students and the teachers that have come. I would say it's a small group, but your students are really lucky, I can tell, because you guys, you're trying to think outside the box and bring new things to your students and connect with them. And they love these things. So hats off to you. I dropped, just FYI for some housekeeping, I did drop the survey. It says tinyurl.com. It's our survey for our kit sessions.
And it's a new one.
It's a new one, yeah. So
Before
it's-
where it wouldn't let you back in, you should be able to go in and see the one for bolts this time.
yeah, so you can just select the tool that we talked about today, and it should work, and everything will be wonderful.
So sometime
Just
next
want to
week-
say thank you for allowing me to sit in. I'm gonna go and do some exploring and do my best with it and get back to you. I have to go. I have a little one that I have to take home now. So thank you so much. I appreciate it.
All right. Thank you for joining us.
Thanks
For
for
next week.
coming, Sarah.
Okay, thank you. Bye.
Bye-bye. So for next week, we're going to share out with you your certificates for participating. We'll make sure that we get your names to Brad so that we can get those. And then we'll share with you the links for these videos that we'll have so that you'll have a way to go back and kind of take a look at what you're, take a look at what we talked about. So yeah.
Awesome. Thank you. I really enjoyed it. It's been
Yes.
very, very helpful. Thank you. I mean, if you want to do a number 3, I'm game. If anybody else,
Me
is.
too, I'm in.
Game.
Oh, that's so
We'll
good
get
to
to Brad and see what we
hear.
can set up, right? Thank you guys so much for joining us, Brad. Thank you as always. Everything is just excellent with you.
Yep.
And we very much appreciate it.
Yes.
No problem. No
All right, I'll
problem.
order
I'll-
them.
Yeah,
I'll-
and
I'll
then
be-
your No, as I say, ladies, if you have questions, you've got we're gonna share also the presentation, so you'll have our information.
Thank you.
Yep, and I'll look
you.
forward to the email so I can get everyone's certificates out to them sometime next week.
Perfect.
You guys have
Awesome.
a great evening.
All right.
Thank,
Thank
you.
you.
Take care, all.
Thank you.
Thank you.
Bye-bye.
Bye.